Members and my dear participants, I am very pleased to present my topic that is a VLC based LOS underwater communication system. These are my contents. Basically, the underwater communication has gained the attention because of its application like submarine communication, navy and military, etc. Previously, the RF and acoustic wave has been used for doing the underwater communication, but this RF and acoustic wave faces many attenuation due to the electromagnetic interference in it. That's why the visible light communication has gained more interest, so that because of its high bandwidth, high data rate and immune to electromagnetic interference. But in underwater communication is very difficult because it faces massive absorption and scattering due to the water molecules, so that the blue light and green light has been used for the transmission, as these have a shorter wavelength and the scattering will be lesser in blue light and green light wavelengths. Here in this topic I have shown a line of sight communication link, that is visible light communication link. Yeah, these are my objective. Here I have designed and simulated a visible light based line of sight underwater communication link. Also I have determined the receive power, and also I have found out the maximum transmission range for different water type inside this underwater communication link. So the first figure shows the basic block diagram where it contains a transmitter, underwater channel and a receiver. In the transmitter, the optical source is nothing but it is a laser or LED. Basically, I am considering the line of sight configuration. That's why I have considered a laser as an optical source, because it is more directed one. And the optical window that I have taken, that is because the same with the blue light and green light. The underwater in underwater communication, the optical beam has been transmitted through an optical modulator, but in underwater the absorption coefficient and scattering coefficient will be get affected, and the extinction coefficient will be the addition of both of them, that shows the attenuation in the underwater communication. So this extinction coefficient is nothing but C, and the absorption coefficient is A and scattering coefficient is B. All the three coefficients are dependent upon the wavelength. So also the different water type has been examined here, and the table 1 give the standard values of absorption, scattering and extinction coefficient inside the underwater, and there are 5 water type. And for calculating the receive power in underwater communication, this is the formula that gives the equation number 2. Coming to, this is my proposed system where user defined data has been taken. I have taken 10-bit data and also tested up to 32 bits, and after that it has been encoded with a NRZ pulse generator. And CW laser, that is continuous wave laser, is working as a carrier to carry the data. Here it has been shown as 1550 nanometer wavelength, that is nothing but it is a green light, and after that it get modulated using MZ modulator. After that, in the LOS channel that is given over here, we can define the water type, the 5 water type that I have already shown in table number 1. We can define the water type. Accordingly, it will take the absorption and scattering coefficient in it. After that, avalanche photo detector is taken. Generally, it is taken for the wireless communication. And after that, 3R regenerator and filter is used to get back the transmitted data in it. So these are the simulation input parameters that are taken over here. So this is the transmitted and received wave. This I have taken for 1 meter distance. Also I have increased the distance for further. And the maximum data transmission range for different water type has been found and shown in table number 3. The pure sea water has maximum range of 420 meter. Now, I have compared the theoretical and simulated receive power. The theoretical power has been calculated using the formula, and the simulated power has been found out using the simulation layout. So for all different type of water type, I have found the theoretical and simulated power, and these power are nearly same, both theoretical and simulated power. After that, the receiver aperture diameter has been tested in comparison with the transmitter aperture diameter. Here I have kept the transmitter aperture diameter as 5 centimeter. Then I have changed the receiver aperture diameter as a greater value than the transmitter one, equal to and lesser than that, and found out that for the lesser and equal value with the transmitter aperture diameter, the receive power has been nearly equals to the transmitted power. Now, concluding my slides, here I have basically calculated the theoretical and simulated power and compare with the and did the comparison with both of them. Also, the receiver aperture diameter has been tested over here, and the receive power that has been received in the optical underwater link, that is better for having a receiver aperture diameter of 5 centimeter and the transmission link of 10 meter, because the transmitted power is 0.383 milliwatt, and I have received the power of 0.315 milliwatt from the simulation. All the simulations are done in OptiSystem Simulator 2020.0, and the plotting has been done in the MATLAB. Yeah, and here I have shown only the LOS underwater link, but for now I'll be, yeah, yeah, sir. Yeah. Yes, sir. Yes, sir. No, yes, sir. That thing I have not done it. Yes, sir. Yes, sir. Yeah. No, no. Okay. Yes, sir. Sir, basically the depth thing that you have said, I'm working on it because. Yes, sir. Yeah. Yeah, understood. So basically, yes, sir. So basically, theoretical power I have been calculated from the formula, that is all. Yeah, yeah, equation based. Yes, sir. Yes, sir. Sir, basically the paper I have found out, lots of paper has been done with the free space optic, that is for the air medium. Yes, sir. Yes, sir. So basically we are designing the layout before doing practical implementation. Yeah, okay. Sure, sir. Sure, sir. Yeah. Thank you so much, sir. Sir, this is optical wireless communication, underwater wireless communication. Yes, sir. Sir, in the
ओपी
सुशांत सर
ओपी कितना नंबर का?
17 सुशांत सर आगे
17
इसी
ओपी 17 चित्रण केला 79 था बेटा को करो.
Good morning everyone, myself Raman. I am Tech EC second year student from the School of Electronic Sciences. Today I will be presenting the topic ODEHNet, that is the optimized deep ensemble framework with hybrid attention for emotion detection. So as we know, emotions are crucial indicators of internal psychological states and cognitive processes. Facial emotion recognition, it enhances our behavioral analysis, human computer interaction and affective computing. The often challenges that will occur during the facial emotion recognition are occlusion, that is like glasses in the face or hand posture, etc., pose variation and some subtle micro expressions. Our objective is to develop a lightweight, interpretable facial emotion recognition model that combines visual and structural features of our face. It employs hybrid attention mechanism for better representation of emotions, and here we use an optimized ensemble framework for better generalization and performance gain. Our contribution is that we use a dual stream ensemble architecture which integrates image based integration network, attention network and a graph based attention network. Here one hybrid attention mechanism combines spatial channel and relational cues, and at the end the decision levels are fused with some late fusion that combines the predictions from both the branches. The challenges that occurs are from the existing papers. The challenges that in facial emotion recognition we counterpart, that accuracy under noise and efficient multimodal fusion and balancing performance and complexity. The method that I use here in the image-based network, two types of dual branch ensemble network, that is an image-based and some graph-based. In image-based, it analyzes the actual photo to spot visual clues like wrinkles, shadows, and shapes. Whereas in graph-based attention network, it connects the landmarks, that is the major face geometry, etc., and the structure of the face. Here an input image is taken, and after pre-processing the data is split into testing, training and validation, and after passing it through our two models, that is the image based attention and graph based attention, after late fusion finally our output is occurred. The image-based attention network, it uses a standard powerful model like Resonate or Efficient as the foundation, and it is enhanced with spatial and channel attention mechanism. Here an hierarchical feature attention module is also used, and that combines both the self-attention and the relation attention blocks. In the dual attention mechanisms, there are two types of blocks, that is the spatial attention module and the channel attention module, where in the spatial attention module, it highlights the critical facial regions, whereas in channel attention, it morely focuses on relevant feature channels. In the graph-based network, it uses natural structure of face via the GCNs. The model works by mapping the face structure. In the two branches, it is parallelly passed through global branch and local branch. In global branch, it captures the general face layout and takes the overall face, whereas in local branch, it zooms into the specific regions to catch the subtle changes that occurs. Finally, it combines the view of both the models, and then after passing it through classifier, it finally gives us the output. Here are the results that we found out from the existing that works have been done. Our proposed model, that is the ODEHNet, outperformed all. It outperforms the priorly existing CNN transformer or Mamba based FAR models. these are the confusion matrix and the graph. Here we can see that it confirms the balanced performance across all emotion classes. It is also robust against occlusion, post variation and subtle expressions. To understand the impact of individual components also, we performed an ablation study on RF-DB dataset, where we found out that even if we replace the key components like the SCAM, HFIM and the GCAM, after that also we are getting the almost the kind of similar kind of results. And we also get that each of the modules of the GCAM, SCAM or HFIM both had significant performance gain. So conclusion, our model ODHNet effectively integrates the both GCN and CNN based attention. It achieves state-of-the-art accuracy while remaining lightweight and efficient. And the future contents will real-time emotion recognition and dynamic on constant environments and cross dataset multimodal experience. Yes, sir. Yes, sir. Yes, sir. Sir, we have sir, the scam and the model, that both channel attention and the spatial attention, that is not parallelly processed. Here we have parallelly both local branch and global branch processed. Sir, thank you, sir.
One second. Sir, Tapos Kumar Patro. Ranjan Kumar Samal. Ranjan Kumar Samal. 162. 162. Yes, sir. 162, sir.
Good morning to all respected professor, faculty member and everyone. So I am Ranjan Kumar Samal. I am doing the PhD under Professor Tapas Kumar Patra. So my research area is that in efficient low power network on chip. So here I am working with one model called workload hour low power network on the modern SoC system core. So this is the contents.
Everyone.
These are the contents as per the our presentation. So if you see here, so what I am working here, so modern multi-core systems use network on chip actually. We can switch off this.
Algebraic number of real zeros in random algebraic polymer.
सर आपण इथे माइक्रोफोन ऑफ कर दियो
ऑफ करके माइक दे दो छी
which is A J omega.
So I'm presenting here one standard SOC. More than 20 master's layer, then the leak will be very complex. It cannot be worked. So layout will be very big actually. So now what happened? We have changed to NOC. Instead of leak and NIC leak, we are going to make a concrete actually. Right side to see the CPU, no? It's just look like CPU. But if you see on mobile, we have, when you buy the mobile, we call this octa-core and quad-core octa-core. Quad-core means we have 4 CPU integrated in that, and octa-core means 8 CPU. And our mobile price also go increase like if there is a quad-core octa-core. And this cores interpret each other, the cache, core, and all the memory interpret each other. So if you interpret with NIC, the whole the layout and everything very complex. So more than 20 master and slave names we have to go to the NOC actually, network on chip actually. And if you see below one, right side below one, is the example of Intel server design actually. You can go for Xeon type of server. So we have hundreds of CPU together as a bunch of together, and that becomes a server actually. Inside all the CPU you can see that DMA controller, PCI controller, many things will be there actually, which will interconnect each other. There's a huge interconnect which is going to work together actually. And compared to other IP, this interconnect itself consumes a lot of energy, which is very good to the SoC itself. So here what we did actually, so this interconnect always on actually, instead of making always on, we are making that this interconnect directly workload hour. As per the work, it should be arc actually. Some of the logic should be off or on. I am talking about bus only. Even IP is taking care of the host actually. I am talking about the bus only. And the workload can be divided with low, medium, high. Like you see in mobile, but only texting, when I am talking the octa-core, but only texting maybe one core is active. Internal is already power mechanism taken care. And if I do the video playing, maybe all octa-core core as well working. But nobody works with the network on chip actually. Everybody works with the core only. So here, how I am going to do this actually, the idea is that, so whatever I am showing that Intel Xeon processor, in that processor you can see the all CPU and everything interconnected actually. So when host is going to give some work, test to work, whether you have video or audio or some different type of tasks we are doing, we can cluster all the CPU and memory can cluster it, and this cluster can be do the one thing work actually. So in our sensing mechanism, if you see right side, we have the IP interacting with the router. So there is a valid and AXI coming on, there is a niche in between also. So we can sense the workload and whether it is sleep mode or active mode. Accordingly, we can sense that, and the clock we can control here. So we can make the cluster wise. I have four clusters. It can be valid 4 to 8 also. So inside that, what happens when working with cluster 1, the other clocking mechanism we can switch off. So it's going to save so much clock switching, and you know power is proportional to clock and switching, and you can save a lot of power here. And here also you can do the DHARA and other mechanism to the more leakage power. But problem is that if you do the DHARA or power getting, the backup and sleep mode will be very long actually. So which will be hit the latency and performance. But clock switching here without hitting the latency and performance, we can save some power. And this is the right side to see that this is the power mechanism, clock getting mechanism, and some timing diagram. And I will put the huge FSM, which is a control mechanism, which will detect the sleep mode and valid mode to control the cluster activity. So this is the I have run with one power tools actually, which will be estimated the different cluster wise power. So there is a lot of power saving if you go to cluster 3 to 10, like you less to more. This is the power saving you can do. And I can show here like we have different cluster. So in between when you are switching 1 to 1, then the power saving is much we are getting. So here what going to conclusion, like This is nothing but cluster level. See, there is a club level and cluster level. Club level is individual club we are going to control. That is very huge actually. So cluster level means we are going to make a group of cluster only. And this activity is driven by club disabling and enabling. So our latency and throughput remain means same actually. Not going to change in the latency. And future work for planning, we can look for the deviation power getting. We need to work with that because we are going for deviation power getting. A lot of latency, sleep mode, and everything is there. So it's depend on the workload, what type of application it is. Whether it's a mobile application, whether it's a server node application. According to the application, we can decide whether we can go for deviation power getting.
Take time, sir. 8 minutes.
Yes.
One question. Can you compare with the existing methods how to receive video?
Yes, actually, we have a lot of this knock architecture and everything. So everybody you see here, the IP are connected with this actually. When they are in suppose in mobile.
You show me table which culture, slide culture. Existing suite culture.
Existing,
Combo covered up to its own. Not really the key to show. But the existing निश्चित power saving methods also there.
but there is say approach करना है जो knock file बड़ा है नहीं कहीं this is I'm giving for any specific application you can do. अपन देखिए mobile is very frequently fast to charge. Whether that application होगा कि नहीं that is different case. This is proposal. If anybody is going to make a workload variant, they can work with knock also. Out switching अच्छी है but the number
तबे 2015 का बहुत बड़ा प्रोडक्ट
register DSC have been to
पेपर पर हम करेंगे.
we are ready to do paper actually that
Okay. Thomas Sandra को आने
next thanks sir.
Next camera.
This is the last time, sir.
Sudhanshu. Sudhanshu आमका जो
by doing non-critical array, we'll save a lot of area and power. And why it is required, as you told, low power, like buffering or storage. Whatever you don't need to go to the next critical array. We can save a lot of area and power. So it is suitable for the high performance SOCs. If you put a lot of unnecessary buffers or memory, what happens is the area of the chip grows, where you could have accumulated more other logic to make it more performance efficient. But the problem is with the CDC. When we cross the clocks from one domain to other domain, and the problem happens because of the stability of the signals going from one domain to another domain. So we need a synchronizer in between to make it the right to read. And here the problem is how to make the efficient arbitrary depth. Arbitrary depth means what are the design depth you need to keep without compromising the reliability or stability of the signaling. Our objective is to design a non-to-the-end asynchronous typo, and we need to avoid more memory space to have more area efficient and without compromising the performance of the SOC. This is how the typo works. When the read and write are in different clock domains, calculating the FIFO, empty and FIFO full is not that straightforward, like what we do with the synchronous the single clock. There will be, if you don't have synchronization between the right side and read side, there will be noise in the empty or full, which may lead to false signaling of FIFO full or FIFO empty that may overflow or non-overflow the FIFO, which will cause the signal override or I will say corruption. This is required because in any server systems, like in banking or anywhere, where you will get overflow, there will be a lot of problems in this. So how we do it? Read pointer to write pointer only compare for the empty, or write pointer to read pointer compare with the FIFO full signal. Then we need to have synchronization between two. But when we have two to the end depth, what happens is the synchronization becomes easy because we use the gray pointer when comparing between the pointers. And gray pointer, the basic philosophy, the transition is only one bit change from previous to the next one. So the stability while doing the clock down crossing is stability is there. But when multi-bit changes, when we have the CDC crossing, then the output may not stabilize in two clocks. So there will be problems when comparing the pointers on the read and write side. So there are 2 or 3 different approaches that the industry follows as of now, like the gray pointer being cyclic in nature. Suppose I need a depth of non-to-the end, I will take n/2 on the top, n/2 on the bottom. But problem is here the starting will not be from 0 or the last point will not be actually my hyper depth pointer. To make things simple, what I try to propose here, what methods I followed is I wrote the code in Actel Verilog and used the dual port SRAM, one write, one read port kind of SRAM, and I had 2 flop stage synchronizers, and before the FIFO wraparound happens, I have special logic which makes sure we don't have an issue in the CDC crossing. CDC crossing is taken care by some gray logic, blue logic there at the output, and what I use is 28 nanometers transistor library with the VDD of 1.6 volt, synthesized with the DC and used frequency 500 MHz. And the power analysis is being done using this tool PPPX functionalities. This is how it looks. If you go with traditional approach, it is the step approach, right? You from one, suppose 32 to 33, suddenly go to the next. Similarly, if you see here, it is a step jump actually. Even if you don't need, you need 34 exactly, you need to put 60 per depth. So power consumption is a little higher. But if we design the actual required fiber depth, there will be linear increase in power and area. The first to show that. And the third graph is showing how the padding overhead because of the extra depth we are providing in case of to the rail, how this is the overhead graph for the extra depth that we provide. Discussions, but the results will get is almost area reduction of starting from 50% till 0 to 50% of area reduction, equally proportional power improvement is there, but problem that we are adding extra glue logic that is eating up 3% of our power and area. But the critical point here is we have to make sure that we have a robust CDC operation. We should not jeopardize our signal integrity, and performance of the integrity should be maintained. Good thing that is scalable, and the technology node we use is from Vietnam.
Good work, no problem. Half trade can move with the cartons with top HLOT, half trade.
Flip-flop, we call it flop in industry.
So we see the part-time move and the flop is
all flop stages. Yeah, this is practical power area efficient, but there is some new logic which is very critical. And
flip-flop is not focus.
but no, it is flip. I use some industry acronyms as future scope is instead of making it manual, we can do adaptive or machine learning based dynamic sizing. So we know the sizing, so machine learning can take care of that.
Any questions? Okay. Next, आयुषी समझ लो देखी
SSC ଆସିନାହାନ୍ତି
ऑप्शन ना
ବ୍ରାଞ୍ଚ ସେପଟେ ବସଛନ୍ତି ବ୍ରାଞ୍ଚ
मैंने देखा देवी प्रसाद सर देवी पर ज्योति प्रकाश मेहरा सूचना बोलिए ମୁଁ କହିଦେଉଛି ଦେବୀ ପରେ ସୃଷ୍ଟି ତାର ତାପରେ ଜ୍ୟୋତି ପ୍ରକାଶ ତ ମାଙ୍କ ଐଶ୍ୱର୍ଯ୍ୟା ତା ଦେଇଛି ଜୟଦେବ ତାପରେ ନରେଶ ତାପରେ ଆମର ପିଲାଙ୍କ ଆମ
ଆଜ୍ଞା ଷ୍ଟାର୍ଟ
Very good afternoon to one and all respected senior members, faculty and dear students. I am Biosensor from School of Electronic Sciences. I am going to present my topic for color and control design for nonlinear process. These are my plans for today. So I have taken heat exchanger as my process. Heat exchanger is a device which exchanges heat between two fluids without any physical contact. This is very important in the industry. So the major objective is to control the outlet temperature of the heat exchanger, and the disturbances could be the flow rate change or the temperature of the steam. So to control the outlet temperature, we need a control system, and the components of the control system are the actuator, sensor, and the control system. So there may be faults in any one of the components. So we have to design a control system, and that is the philosophy behind the fault control and control, that we have to design a control system which can maintain the system performance even in the presence of fault. If fault happens, what will happen? Because if there will be fault, it may lead to damage of the equipment, production loss, or there will be environmental hazards. If we design a fault tolerant control, it can minimize these effects, like it can minimize the downtime, reduce the operational risk, and maintain the control performance. So there are different faults in a process. It can be the sensor fault, actuator fault, process fault, or the control system fault. Sensor fault means if there is a change in the characteristics of the sensor, then it is called sensor fault. Or if there is a actuator like a control valve, if there is blockage in the control valve, it is known as the actuator fault. If there is some chemical or mechanical issue in the process, it is process fault. Or control system fault, there is hardware or software failure of the control system, it is known as control fault. So there are different techniques to design the fault tolerant control. It may be based on model based methods, or it is data driven methods, or redundancy techniques or reconfigurable control systems. So in my project I have used the reconfigurable control system. Objective is to improve the plant performance in presence of disturbance and parameter uncertainty, and to validate this using the simulation, and to analyze the characteristics of the dynamic behavior of heat exchanger in presence of around a normal and fault condition by considering mostly the actuator and sensor faults. This is a basic feedback control system. Here I just want to show you that the disturbance could be the flow rate or the temperature of the steam. But this the heat exchanger process is modeled using energy balance method. So here the heat energy in minus energy out equal to energy stored. So if we can reduce to the transfer function form, it will be represented as a fast order system with time limit. I have used two controllers, PID controller and FOPID controller. PID controller, there are three parameters to be given, KP, KI and KT, but in FOPID, two more extra parameters are there to be controlled, like lambda and mu. I have designed a cascade control system where there are two loops, one is primary loop, the secondary loop. Primary loop controls the outlet temperature of the process, whereas the secondary loop tries to minimize the disturbance before it happens the primary control variable, that is the temperature. So in inner loop, the secondary loop, I have used one feedback loop, that is the secondary loop, where it will reduce the disturbance, that is the flow rate change of the steam. So the two controllers I have used, first I have taken PID and tuned with Ceremonial method, Nichols method. Then I have tuned the same PID with PSO algorithm. Next I have used two FOPID controllers and tuned with same PSO method. So these are the tune parameters I have obtained from Nichols method and particle storm optimization method. Next I have included the fault. So here I have considered the sensor fault, drift fault and bias fault. So to control that, I have first developed a model, that is by using system identification method. System identification is the process of designing a mathematical model of a physical model by considering the input and output signal. Here actually I have taken from the system itself the transfer functions, but if there is a physical system, we can also model in the same way. So the model gives the response which is most similar to the physical process, but it is not same. But as I have taken the transfer function, it is the same response as the transfer function is giving. So there I have introduced a drift as well as a bias on the sensor side. So if there is some bias or drift, then it will compare with the ideal value, that is the output of the model. If there is a drift or bias, it will switch to the model as output rather the sensor output. So these are the outputs I got from the simulation. First one is the red color is the PID tuned with Nichols method, and the two in pink and the blue color, the pink color is the PID tuned with PSO, and the blue color is FOPID tuned using PSO. It is clear that the settling time has drastically reduced from 500 seconds to 220 seconds when it is tuned with PSO. But in PID and FOPID, the settling time is better in FOPID. So these are the simulation results when the drift is introduced and the bias. So figure 6 shows I have given the drift at 350 seconds. Still the response of the process remains same as the model response. Similarly, in figure 7, the bias is added to the sensor. So that means there is a fault in the sensor. Still the response is giving better or same as the model response. So I can conclude that the PSO based tuning resulted drastically reduce in the settling time, and FOPID has better rise time as compared to PID. proposed fault tolerant control effectively maintains the system stability and performance by detecting and compensating the sensor fault, ensuring reliable and robust operation under faulty conditions.
The work looks good. What is the equation? The constantly kind of equation is this one. The rows if we this is the first one. Second side, why do we take EI minus TO? It should be output minus input. And accordingly, the minus this should be minus UA. Because the kind of heat to the fluid minus the heat loss. Heat loss equal minus UA. So in my opinion, it should have been rho Cp TO minus TI minus UA into T minus TS.
Set value minus set point minus measurement. Set value. Here. So the error is generated. Set value minus the sensor output, the measured value. T0 is the outlet temperature. Ts is the set point.
No, I for inlet, O for outlet. Simple logic. And see, first one.
Okay.
On the right side. The TO minus TA, because output fluid temperature minus input fluid temperature, the heat quality. But in that also there will be some heat loss to the surrounding. That TS minus TO. It's okay. But there should be minus UA. It's not cross. You can cross UA to difference of T. You got my point? The first one will be
that equation.
the first one will be
I have not designed this actually. I have.
I got it now. So this would be first one will be m dot Cp into TO minus Ti within bracket, then minus UA into Ts minus T. Just check it in the source will taken.
Okay.
I think that's pretty from there.
Next.
Okay, come.
Next also the
Shruti.
Sufi is son of Sami.
Good afternoon, respected jury members and dear legislators and myself is Biosensor, and today I will be presenting my work on a secure and intelligence framework for predictive maintenance in Industry 4.0. It is integrating XAI and uncertainty quantification. These are my content. And industrial IoTs produce a lot of data. So this is evolving into a complex cyber-physical systems. If you were present in the last survey, in the opening remark, Professor was giving regarding this system, cyber-physical systems, and operational technology and ITS are increasingly convergent. So earlier what was happening is IT systems and OT basically level 2 and level systems were separate. But right now, since AI or machine learning, whatever is coming, so they both has to be merged together. So security becomes a critical component over here. So traditional predictive maintenance model rely heavily on centralized cloud computation. And this introduces latency, privacy risks, and they reduce real-time responsibilities. So whenever we are sending all the sensor data to cloud, it is taking a lot of bandwidth and also time and throughput. So it comes to the latency. So additionally, deep learning models often function as a black boxes, limiting operator trust. So obviously, whatever we right now we are working with LLMs or different kind of At that time, we don't know what is actually exactly happening inside that. So here what we are proposing is age computing. So basically we will be implementing inside we are getting the data from the sensor, compute at the edge, then send the data required information only to the cloud system.
Deep learning
Deep learning also will be implementing in that system. Like let's say there are 10 sensors, we will be computing the 10 sensor data in the edge computing. So what is my objective? To decentralize predictive intelligence to edge devices for real-time operation, to integrate explainable AI for transparent and interpretable maintenance alerts, to incorporate uncertainty quantification, to reproduce false values, to align the framework with risk-based OT security principles, to create a scalable security architecture for industry 4.0 environments. So different methods, materials and methods we use is high fidelity imaging health monitoring data sets. So basically we have taken this SAP, NASA SAP data sets, deep neural network architecture for fault prediction, SAP time for model interpretability, multi-color dropout for uncertainty estimation, and next RNA-0 architecture, zero trust security framework. And this is the like architecture. So like three layers here. The architecture consists of 3 layers. The sensor layer collects time series data. The edge interface layer performs dual attention rule predictions, remaining user life, useful life. The XI and uncertainty modules provide confidence and interpretability. Finally, alerts are generated locally without cloud dependency. So basically, if you will, I will explain in the simple terms, whatever data we are getting, we are deploying the deep learning in the like edge, it is like a small computer, and we are going to processing everything over there, and we are generating the alert, and then we are processing like sending the data to cloud, whatever is required, not all the data we are sending. So again, sensor data is collected from industrial machines. A deep learning model processes partial or temporary of features. Inference is deployed on edge devices to reduce cloud dependency. Predictions are passed through XI layer for explanation. A EQ model assigns confidence score to each prediction. So this data, basically this last data is being sent to the cloud, not all the data. So zero trust architecture ensures continuous authentication. I think in my last presentation I had talked more about the zero trust architecture when we have large volume of sensors. So it becomes like a problem how to authenticate that we are getting the data from the client sensor, or it is our sensor and there is no third party have entered to our network and they are pushing the data. So certificate based verification secures OT communication, OT means operational technology. Generative AI driven policies enhance anomaly detection. Niche OT security guidelines provide structured implementation. The system ensures resilience against cyber physical attacks. These are just some results. Preliminary evaluation indicate approximately 40% reduction in transmission latency. So basically, whenever we are sending the data to cloud and we are again doing the computing and getting the alert, getting the response, by deploying this edge computing, we are able to reduce at least 40% latency. Edge deployment minimizes round trip cloud communication. This enhances responsiveness in time-sensitive automation systems. The framework supports real-time maintenance alerts. These are the results. Preliminary validation shows 90% fault detection accuracy. EQ model identifies out of distribution data scenarios. Simulation suggests potential reduction of unplanned downtime by 30%. XI layer improves operator confidence in maintenance decisions. Their discussions, edge path architecture reduces operational latency. Integration of XI addresses the transparency gap in AI systems. UQ reduces false alarms and increases reliability. Zero trust framework against OT cybersecurity problem. Large scale industrial validation remain ongoing. This is the conclusion. This framework combines LGI, XI and UQ and security proposal.
transmission latency ko
Generally, I mean, industrial sensor, there are 1,000 models. 1,000 models, we are checking the vibration, temperature of the sensors. So they are sending the data to my router. So router send to again cloud and to server. Parameter simple data set. Basically, sensor data to correct it is in like digital format, then again we are converting it to a message level format. So same data I am sending it for processing. What were, let's say,
industry 4.0 how so I think it is happening.
no, but this zero shift at the age computing, it is also cloud and also. So again, the way I am working with the major manufacturing partners, so I know like they are doing it, but it is everything is being done in the cloud. Cloud is also immediate alert. Suppose a message is going to stop, so immediate alert you need to deploy age computing approach completely in the factory
So
itself.
what is your proposal method?
So we will like the routine to I mean the culture.
No.
I'm just doing something. See, I mean, NVIDIA nano jet nano. Okay, it is able to complete deep learning also. So it costs very less, maybe 20,000 rupees. So connect it to maybe 100 sensors. 100 sensor data will go to that instead of going to cloud. So local network it will process it, it will start sending that.
Next.
Next.
आपको पता नहीं है किसका था? ना सीधे
OP.
हाँ
88.
ज्योति प्रकाश
कैसे जाने?
चलो ज्योति प्रकाश जो तब दिया ऑप्शन है जो
थोड़ा माफ करो।
बाद मैं ऑप्शन अछंती आयुषी सामंत सिंह आउ हला ज्योति प्रकाश बेहरा
देखियो लास्ट में यदि
से पिला के
से एपीजी रो से ओपी
88 ओपी 88 मुरो चेक कर दो आपन डाटा मोर डाटा ठीक अछि चेक कर दो
सर इधर से कोऑर्डिनेटर्स
Good afternoon, everyone.
Yes, sir.
I am Jaydev Rao from 7th semester. Today I am going to propose my solution for the underwater image enhancement. I am proposing a solution named as adaptive multi-scale contour morphology with semi-grade recovery. This is the content. For the introduction part, 70% of the world area of the world is covered in the ocean. But the part is the images taken underwater is difficult to process for the research works. Mainly the red color inside the ocean is easily absorbed, so that way when you try to capture the image, the red channel is not properly visible. And there are multiple challenges associated with it, such as forward scattering, backward scattering, and low contrast. As a result, there are haze and bluish paintings around the image, which makes it difficult to process. Also, if it is processed, sometimes it gets over-processed. The proposed solution, as I said, ANCB and SSR, combines multi-scale enhancement with intelligent red recovery. For the objective part, we want to recover the red wavelength. With that, we want to segregate the boundaries from the foreground and the background. So that way, there will be over-processing of the whole system. More to that, we are making a robust mechanism that detects the shallow depth of the water, so that when the light hits the object, the reflection of it can also be calculated, and hence the adaptability of the model can be also determined. So we have done the shallow, medium and deep water conditions for that. So talking about the materials and the methods, so we have a flow of it. First, we want to semantically segment that whole picture into foreground and background, so that it becomes very easy to make the processing part. Second, comes the water type classification, if it is very deep, medium or shallow. So third comes with the multi-scale contour morphology. Fourth is the semantic rate recovery to recover the red channel. Also the adaptive multi-scale contrast stretching, and also the final reconstruction. Directly talking about the semantic segmentation, we want to segment the foreground and background, because in the background, which is mostly water, we do not want the red channel to be recovered, else the water will look very muddy. So we want the foreground thing to be focused more. So that way, sir, we have derived equations. In the first step, sir, we need to make the whole image to the grayscale. So to know the luminance factor, sir, if we talk about the weights that I have given to the green, red and blue, it is the reason because sir, our eyes processes colors differently. For example, green is more sensitive to our eyes, so I have given more weight to it. This is the experimental factor. So second equation is about the edges saliency. So that way it exactly tells how is the where is exactly the edge after the illumination factor, sir. When we do the gradient thing, if there is a sudden change in the brightness, sir, it will show a higher value of E. Again, sir, about the distance transformation, if you are focusing on a particular pixel of a foreground, we need to exactly map how much it is different from the edge. We are using an equilibrium distance formula there. Similarly, going with the foreground masking, so if it is a foreground, then you can show 1, and if it is 0, if it is a background, there is a threshold value which is determined on the basis of the depth of the water. And as I said, the weight of the weightage is given on basis of the depth, and that way the background and foreground separation is done. We want the background to be less processed and the highly processed to the foreground. So that way, sir, all the necessary images that we want to be focused, like just like a fish or a big coral, that should be in the frame and should be sharp enough to do the research. So about the water type classification, we have a formula, and where I max represents the maximum pixel intensity. Similarly with the I min and ISD. So with the water type range, if the H lies below 0.30, then the water is classified as shallow water. Similarly for 0.30 to 0.6, it becomes medium, and for the 0.6 to greater value, it becomes a deep water. So that was the classification is first done. So about the multi-scaling, which is different from the previous paper. So actually in the previous papers, contour part is done, but sir, the multiple scale is important, sir, because fish are of different sizes. We want to know that if a fish is very small, we cannot apply a 11 plus 11 structuring element to it, sir. So we need to add a 3 cross 3, similarly followed by 5 cross 5 and 9 cross 9 up to 11 cross 11. We cannot go to some higher values, as you can see in the figure B. So we are only focusing on the edge part, not in the inside part, sir, because if we focus on the inside part, the more smoothing will happen. So that is the focus that we want to make on the foreground. It would be the details would be lost. So that way, sir, we are using only the odd numbers because, sir, we want to get the exact center of the pixel. So similarly, we can see the small CB to medium CB to large CB. Also, sir, I discussed why we are using the CB which is hollow, contour. So about coming to the red recovery part, so we have made a formula which is a difference of red from green and difference of red from blue itself. So that way, sir, because green comes in the spectral level of red.
Record that equation, this equation.
Sir, the equation is already there, but the 0.5 and the 0.15 weight that we are given, so it is experimental.
Arbitrarily you can give the coefficients.
No, sir.
5 years. Reference 5 years.
Sir?
Reference 5 years.
Yes, sir. Yes, sir. For the reference 5, sir, they have chosen the weight which is difficult to map for the depth of the water, sir, because our depth of the water classification is there. So it changes, sir, with the difference part. So we are getting taken an inspiration from the reference for the equation part, but the weight is that is what we have made experimentally. Sir, about the adaptive contrast stress, that is important, sir, to know the to make the brightness and the dark part of the image evident, so that it becomes really easy. And sir, for that we can use it for the foreground to get stronger contrast and make the object clearer and sharper. So this is the result that you can see. Sir, in the middle section, this is the CBM, this is the previous paper. So the red is getting more intensified, but in the final output that we have achieved, it is that the red is getting not that much intensified, which is very important because the red part makes very kind of a the red part exhibition makes it very difficult for the image to know exactly where the actual red is present in the image. So similarly, comparing the results with the previous methods that I have proposed. So this is the contrast part and the red intensity with the percentage mentioned with the edge value and the edge value. Now this is what we want to achieve in the whole paper, that is the natural and the balanced tone, not to sharpen or to over smooth. and with the high clarity and and the sharp edges, which is most important. And so this is the with the conclusion with the whole proposed method. So we are achieving a red intensity increase of 12% to 34%, followed by a contrast improvement of 0.8 to 0.41, which is 120% clear visibility. Followed by a Hess reduces from 0.68 to 0.22. So that way the AIDS improvements and the UCIQE and all the overall parameters are also improved in the whole solution of the problem.
Okay, go to the previous slides. You have compared the results which is the paper that is published in 2021.
Yes, sir. Yes, sir. The work is done, but it is on the basis of AI and deep learning, sir. But we have not.
20 means it is published in 2000 with iterative transaction.
Yes, sir.
That means it was the work done 19 or 20 actually.
Yes, sir.
After say 6 years passed, you will compare with that.
Yes, sir. Sir, the fact is, what we are actually doing different is the water classification part and the multiple scaling part. But the existing methods are uses AI and deep learning into it, so that that becomes more and more heavier for processing part. But sir, we are, as I said, with the water and the classification part, so that is different and very new. So that part isn't achieved right now.
No, but can you compare the computational complexity aspects when you are claiming that this is intensive? So you should have compared the computational aspect of your algorithm and the ones that are making use of AI or anything related stuff. So just go back, I'm curious, just go back to the previous slide because you are claiming that the contrast has improved and the edges have become sharper. So just go to the figure and tell me where the edges have become sharper.
Ma'am, exactly you can see in the middle image. So the edges have become.
No, use pinpoint. You highlight where exactly the edges have become sharper. Because you claim so, how do we know? You have to pinpoint or highlight that area where the edges have become sharper.
Ma'am, the edges of the divers who is driving inside the whole into the sea. When the edges they have become sharp, if you can see, you can zoom in.
No. Middle figure and the rightmost figure.
Yes, ma'am.
You almost said, no?
They were almost same distribution.
middle figure looks good.
The middle one looks much better.
Yes, ma'am. Now it is a PNG format and we made it in this screenshot format of.
No. Then you should have kept the format same.
Yes, ma'am. That's the downloading.
See, I cannot now.
Otherwise the comparison.
Yes.
No, the format should remain same because to me both of them look almost the same.
Almost same. If you will.
Ma'am, in the red part, if you can see focus, ma'am, the red.
Okay. What did you say? The edges. I'm not commenting on anything related to red part. But you claim the edges have become sharper. Okay, and contrast has improved. So I just want to know where it has happened.
One thing that you should have to include the SSIM, structural simulation, in the index, and loss in the region. Okay. Next.
This is समय लगे ताकि compare करो ये गोटे format से वो तो comparison नहीं नहीं बड़ा समय लगेगा कि बिल हाँ setup
Good morning, everyone. I will be presenting on the topic polarization drivers, dual band metasurface inspired variable antenna for reliable 2.45 5.8 GHz body centric communication. So these are my contents. So normally communication means sending or receiving of information from one point to another point, and then it can be divided into two parts according to the medium. So one is your wireless medium, another one is your wired medium. And in wireless medium, the WBN, that is your wireless body area network, basically it is very, very important application. And in this WBN application, antenna plays a very, very significant role. So in WBN applications, there are three types of communication that can happen. One is your off-body communication, second is on-body, and third is in-body. Off-body communication is communication something from the body to the outwards. The on-body is, let's say, two type of things that is communicating from itself on the body itself, and in-body is, let's say, some parameter that is already inside the body. So let's say pacemaker basically, and that is communicating with the outer world. And so this kind of application basically used in military. It can be used in the medical case, or it can be used in the rescue operation. So this is a simple example of this one. And as this communication happens, so obviously we need the antenna. So this antenna plays a very, very important role. And these are the frequency band where this antenna can play a very, very important role. Like in the ISM band, it is 2.485 GHz, and the second one is 5.725 to 5.875 GHz. So I'll be mainly concentrating on the ISM band, that is 2.45 GHz and 5.8 GHz. So while we are going for this meta surface based antenna, so in the WBN application we need a planar type of antenna, and that can be done through either a microstrip antenna or a CPW fed monopole antenna. But in microstrip based antenna, it has the basic disadvantage of narrow bandwidth, so that's why we are going for a monopole antenna. But again, the monopole antenna has some limitation, like it has some back radiation. So due to the high back radiation, it increases the SAR value, and that cannot be directly used for the WBN application. So that's why we have the two solutions for that. One is your meta surface based antenna, and the second one is your PEC based antenna. So what is a PEC? PEC stands for a perfect electric conductor. So PEC also acts as a reflector basically, and that is used to reflect the radiation from the antenna towards the body. But in case of PEC, the wave basically transfer at a 180-degree phase shift, and when it added with the forward radiation, it decreases the efficiency and all the gain parameters and different characteristics of the antenna. Whereas the meta surface, that can be easily used for this WBN application due to the 0-degree phase reflection. So it shows the 0-degree phase reflection at the range of frequency. So at that time, the wave propagation or the radiation from the reflector basically it acts as a constructive interference rather than destructive interference. So that's why we are going for the meta surface based antenna for the WBN application. So the meta surface, it is basically meta stands for your artificial basically. So that is not naturally available. The PMC perfect magnetic conductor, it is not naturally available. So what we are going to do with the meta surface, we are going to design a unit cell basically that shows the 0-degree phase reflection part. Then after this, we can arrange this unit cell in a periodic manner to create the artificial magnetic conductor. That is basically called as AMC. So this is a simple example of a meta surface. So it is a 2D structure basically. Okay, so in this case, my objective is to design a dual band, dual polarized meta surface based antenna. So the objective is divided into two parts basically. So one part will be I will be designing the AMC part, that is your artificial magnetic conductor. So for that I will be designing a unit cell that will be uniting at 12 band, that is your 2.45 to 5.8 GHz. At the same time, I will be concentrating on the polarization conversion. So because in the variable antenna basically, in the variable communication, we need the antenna to be circularly polarized so that the movement of body does not disturb the antenna orientation as well as the radiation pattern. So that's why I will be more focusing on towards the polarization conversion from linear to circular polarization. After that, I will be designing a dual band antenna at the same frequency 2.45 and 5.8 GHz. Then the antenna will be integrated with the meta surface. So I have taken a 2x2 meta surface over here to conserve the compact size of the antenna. And then we will see the output whether the antenna is receiving the dual band characteristic and circular polarization is happening or not. So this is objective is divided into two parts. So this is the unit cell design, the meta surface. So you can see in the first example, if you take the first diagram, so I have taken a traditional unit cell design. Okay, so that unit cell is uniting at 4 GHz. So below figure number 1 is the simulation result for all the 4 unit cells. In the second unit cell, what I have done is I have something gigahertz. So in the last four unit cell basically, what I have done again, I have added a extra L slot basically, asymmetrical L slot to decrease the frequency from around 6.2 or 6.23 gigahertz to 5.8 gigahertz. So I have given the frequency intended in the green line basically, so that shows the frequency of interest at 2.45 and 5.8 gigahertz. The figure 5F basically, it shows the reflection phase characteristic of the final unit cell, that is the L-shaped unit cell basically. So you can see that at 2.45 and 5.8 gigahertz, I am getting a 0 degree phase reflection. So I can say that the unit cell is basically acting as a meta surface. And the unit cell has been electrically, the equivalent circuit has been designed for the unit cell, the final unit cell. So the outer ring basically it acts as a series parallel series inductor and capacitors, whereas the inner page as well as the L cell it acts as a parallel connection of inductance and capacitor. And the same has been simulated through a QCS software. So and the antenna has been validated as the simulation result has been validated with the simulation result of CST Microwave Studio. So that gives you both the result. The second part was I want to go for the polarization conversion. So in the second, in the figure number 6, figure number 7 basically. So at the higher frequency band, that is 5.8 gigahertz, so there is a conversion, there is a connection between the co-polarized and cross-polarized component. So in that case, the co-polarized and cross-polarized is overlapping with each other. So that gives me an idea about that there is a more to the polarization conversion. So basically, whatever I am giving a linearly polarized antenna, so at the higher frequency range, that is 5.8 gigahertz, I am getting a circularly polarized antenna. So these are the parameters of the unit cell that I have taken. The second one, as I was saying, that after the unit cell design, basically I have taken a 2x2 meta surface. So figure number 8B basically that is a 2x2 meta surface. Figure number 8C is the dual band antenna, simple dual band antenna. And then figure number 8 I have integrated the dual band with the AMC. And the figure number D is the dual band antenna with AMC on the on body. Which I want to see the characteristic of the antenna on the on body or close to the body proximity. So that's why the figure number 4 is with the full body model basically. So if you look at the different simulation result in the figure number 9 basically. So figure number 9A gives an idea about S11 versus frequency plot. So in this case you can see that the both 12 band and simple 12 band antenna without AMC basically it is also originating in the 2 frequency band, whereas the both antenna with the AMC also originating in the same frequency band 12 band. And when the antenna with the AMC, that is your body model basically it is also originating in the same frequency band. If you go for the gain versus frequency plot, you can see that the normal antenna is giving me very less gain, whereas the antenna with the AMC is giving a higher band at both the lower frequency band of 2.4 as well as your 5.8 gigahertz. Similarly, if you go for the efficiency, the antenna efficiency does not change when the antenna is placed near to the human body. So this is a very important parameter to look into the WPN application. The second one is your circular polarization. So whether the antenna exhibits the circular polarization or not. So that can be seen in the figure number 10A basically, that is your gain and axial ratio plot. So if you look at the axial ratio plot, that red line basically it goes below 3 dB. So at that point 5.8 gigahertz it exhibits a circular polarization. So this is the antenna that we have fabricated basically, and the same antenna is used in the body model. So you can see that the simulated major result basically it is also giving the dual band characteristic and the same and the same. So this is my work has been compared with the previous literature work. So I can say that this antenna is of less size, so compact size 60 cross 67, and it is giving a higher bandwidth of 1750 megahertz as a higher frequency band with a gain of 7.89 as well as circular. Thank you.
So when you are talking about body wearable antenna, what is the size and is it scalable kind of thing that commercially it can be exploited and or manufactured?
Yes, the commercial it can be exploited, but again at the same time size is very very important. But as we are using the antenna on the body basically, so we can't use a higher antenna size so that.
We understand that, but the point is, which device will make use of it? Is it a separate unit or it is to be embedded with
No,
something
it
else?
has to be embedded with the like in our smartphones, so we have the antenna basically.
So then what should be the size of it?
Depending on the application, like say let's say some rescue operation, so somebody can wear it on
Just
their
not
head.
see. Any day because you talked of a smartphone, smartwatch. So smartwatch everybody is wearing these days. So what should be a typical size and commercially can it be really embedded in such a structure?
Yes, madam. It's, like in this, in my cases, I have used the antenna for a 67 cross 67 millimeters square basically. But if you look at the this one, basically it will be of 4 mm or 6 mm antenna size. A very very less size.
Then you should compare your data with the one which is commercially available, so that you can claim that yes.
You compare.
Yes, yes, but we are not designing this for the commercial matter, but I have compared the data with the previously available antenna.
See, if you are going to embed it using a wearable device, then it should be commercially made. And then the data that is available, that should be compared with you.
Okay, I will look it.
Okay.
Even the last, the confusion, it's a well optimized trade-off. I don't think this is the right term because he has done some parametric study kind of thing. So optimization needs, number of design experiments kind of thing. Simple kind of thing like varying some sizes and some wavelength, some things. So parameterization has been done, but not optimization has been done. So the claim is something
well optimized in the sense that I have compared with the previously available data basically. So you can see over here basically. So some of them are giving a good.
That is what he is correct. You cannot claim that it is optimized. It is giving better performance. Better result. Optimized means you have made use of some function using those variables and then come out with your optimized solution.
I am saying well optimized trade-off between compact size, wide bandwidth and acceptable gain.
Well optimized trade-off.
Trade-off between. I am saying the trade-off between.
So that is not going to work.
Work is okay, work is fine.
Well optimized trade-off.
Trade-off basically because
acceptable trade-off.
Acceptable trade-off is well optimized. ठीक है.
thank you.
Next Kamila sir. OP92. OP92. Sudham sir. OP92.
Good afternoon everyone. My name is Kamila Soil. So I am here to present my work. It is the comparative analysis of engine integration effect on empirical biosensor performance in medical applications. So before you move to the next slide, so we have to understand what is the engine inhibition methodology which is to be impacted for the biosensors. So already we know this is the contents and these are my introductions. So we know the biosensor is basically analytical devices, or it is going to measure the current with respect to the biochemical reactions. So that's why the question may arise that why we are using the experimental biosensors. So as it is a part of the electrochemical biosensors, so it can be divided into two types. One is the empirimetric, one is the conjugametric. So I have chosen this one empirimetric because it is in one advantages. The parameters for the empirimetric biosensors, it can be embedded with the multiple features, and it comes with some properties like the selectivity, the reaction rate, or we may see there is a compact size. This can be some of the parameters which may beneficial to designing biosensors, the empirimetric biosensors. And we know the empirical biosensor in day-to-day life, it can be used for the pocket devices, or it is the point-to-contact devices, or it can be variable small size, or there is no expertise to be required to design the empirimetric biosensors. So here are two figures are to be represented. One is the schematic representation of biosensors, and this is consist of three components. We say there is a W, E, R, E and C, E, and these three components have the different significance. One W is in working electrode, and which is the basically electrode operation is to be transferred. We are going to be select the electrode at the working function there is a working electrode which is basically where the yes sir W is a working electrode. C is a cathode electrode. So where actually the current generates is going to be amplified for the better results. And the reference electrode which I am going to use it here is the reference, which is the 450 millivolt. And in the right side, some of the samples for the enzyme samples are to be used, and each there is the reference are to be the first generation, second generation, or the third generation. Where basically the biosensor, the device is to be in something, and it consists of the biomaterials. This having the age of the biomaterials, and it is going to be devices. It is going to have the properties, the ability to detect the analytes from the environment. So here the analytes which I am going to be using here is a enzyme, and which is going to be talking about the inhibition properties. So it is basically to slow down the process. It is going to be reached to the body membrane. So that's why it is part of the biosensors. And here my objectives are that to develop a unified kinetic diffusion model incorporation enzyme inhibitions. The work is done differently for the enzymes working as independently, or here we talk about the enzyme inhibitions. So here I am going to be using as a binding effect for the diffusions between the cell membrane or the external membrane. So that's why the first one should be the homo enzyme of the concept I am using over for the different physiological conditions for measurement of the resistance, the sensitivity, the rate of reactions are to be measured over there. The second one is to model the cascade biosensors and investigate the propagation of the inhibition effects in the multi-enzyme system. So if you talk about the homo enzyme and the hetero enzyme are to be proposed over here, that they are having different the individual work has to be done, and they are going to be slowed down. If they are using the two different models which are going to be implemented over here. One is the competitive type of the methods, one is the non-competitive type of the methods which I am going to be used here. Means there is a comparison between a single enzyme effect, there is a multi-enzyme effect, how it is going to be beneficial, and it can give you the results, because there is a, sometimes there is a, due to the chemical reactions we may get the results we may get, or it may reduce the efficiency of a device. That's why there is a first to analyze the individual performances using the homo enzyme or the hetero enzyme under the different physiological conditions. The next come to the cascade biosensors. It will sequence of, there is a multiple, the sequence of the enzymes are to be arranged in such a way that it can gives you, it means there is a chain of the enzymes to provide you the better performances in terms of the, it means to reduce the extra enzyme to be over there. So here some of the materials which I have used, the enzyme, the target enzyme which I have used, the substrate solutions, some of the physiological concentration range within the some boundary conditions from the D, there is the some of the membrane diameter, there is the some nanometer, 2 nanometer which I have discussed over here. There is an inhibitor compounds, there is a methodology, the competitive or the non-competitive type, and the last one is the buffer solutions. These were some of the physiological conditions to measure using the competitive and the non-competitive type of the methods. And here are some of the mathematical models. So the first, the equations to the modeling will be the presented is the competitive inhibitions and the non-competitive inhibitions. It says whenever any body is going to be, there is an interactions of an enzyme in the antibody is a substrate. Okay, the substrate there is a one difficult size of an enzyme, and this size is interacted with the another substrate. It means different shapes is provide you the different rate of the reactions. So here is the two comparison happens between the competitive. So here is the interaction of the extra inhibitors at the outer locations of the enzymes. So maybe it doesn't directly affect the processes, but the non-competitive inhibitions where the actually there is a no interactions of the enzyme or the substrate may happen. The diffusion might not happen. So due to this, there is an increase of the current. So because of this, there is a probability of the device might not work properly. That's why I go for the competitive inhibitions. So where actually the chemical process happens, or due to this, it may slow down the process or the program for the enzyme reactions might happen. And that's why there's some of the equations for the single enzymes, and which I have designed as biosimulations modulations. Here the hetero enzymes, so enzyme 1 or the enzyme 2, to convert the substrate to the intermediate or the convert the intermediate to the products, and which I have using these two equations in a biometric
equations have already been developed.
because there is a, before start the process, or we talk about the no boundary condition or the boundary condition of the process about the diffusion, so the enzyme. And you can see there is a diagram for the bulk solutions. There is no reaction started, and yes, we are having, before we start the process, there is having some of the molecules, that means small volume of the molecules have to be transferred to the, there is equations you can see for the competitive and non-competitive inhibitions. The V is called V max S by Km. Let us talk about
continue.
conclusion देखिए तो very good.
I have something to ask in the question. No, no, sir, पूरा letter complete.
So here the thing compartment talking about, there is a bulk solutions. Now before we start the process, there is the bulk of the analytes have to be present over there. So before we go for the process, there is a small amount of analytes to be entered to the next process. The equations is to be like this is the common questions. This is the E, that's the enzyme is added to the substrate. It gives you the EI. The product is to be the EI, the enzyme or the intermediate. So talk about there is a combinations between the bulk solution to the enzyme layer. That means started already the diffusion already started. Is the substrate. What it gives you the result. Okay. So that result is going to be now the next three combinations with the E. Already talk about E plus S. This gives you the EI plus the product. That's why there is a P is the product over here. Then there comes the next equations in which is the product is to be now to be added for the next equation, the enzyme, the product which I have got it over here. It gives you the P electrode result. That means the electrode we're talking about the working electrode. Through this electrode we are going to amplify the signals to get the result in terms of the small current. And we have the sum of the compartment, the bulk solution is where the actual the chemical reaction happens. There is an enzyme layer, the electrode regions. The species we talk about, there is some of the parameters are to be defined with respect to the value, the numbers of the value, and which the inputs are already given.
What's the result?
Okay.
There's a conclusions, ma'am.
Okay.
The results.
So the competitive and non-competitive emissions have a different ways, and that is basically talk about the sensitivity, how much the biosensors should be sensitive compared with the competitive or the non-competitive methods, and this is to be done through the different simulation models. And to get the competitive methods is to be the more beneficial. It gives you the lesser amount of the current to be using for the betterment of the biosensors.
So if you don't mind, I would just ask you one question. You just go to the equation slide, like equation 3, 4, 5. Okay. Here see current output I.
Yes, ma'am.
You have a bracket like ES. Does it
Yes, ma'am.
represent the average value? Because
Yes, ma'am. Yes, there is the equations we will go from the enzyme plus substrate.
no, whatever it is,
Yes, ma'am.
product of PS and that square bracket usually it represents average value,
Yes,
which is
ma'am.
a constant.
Yes, ma'am.
Which is a constant.
Yes,
Once you talk of an average
But I
value,
have given the fixed value I have taken. That's why.
no. Does it represent the average value?
Yes, ma'am.
Okay, fine. Then in equation 1 you have simply S.
Yes, ma'am.
Just look at that.
Yes,
In also equation 2 you have an S.
okay.
Okay.
Yes, in the
And
substrate.
then when it comes to equation 4 and 5, you are differentiating the average value of S.
Okay.
Is it so?
Ma'am, is the already the equation should be solved. I have given only the part which has to be similar over here.
No. That was not solution part. I am not asking whether the equations are correct or not. I have a doubt.
Yes, ma'am.
Because when you are differentiating
Yes, ma'am.
S, square bracket S means it is an average value.
Okay.
And average value is a constant.
Yes,
If you differentiate it, it becomes 0.
Yes, ma'am. Because some of the values I have taken as zero value, ma'am. Yes, ma'am. Here.
No. What is there to solve there?
Ma'am, I am using the reference values which I am using over here. For the substrate, you can see for the bulk solutions, I am using the volumes, the large volume of the.
No. I just want to know the difference between S and bracketed S.
Ma'am, the bracketed S is all about there is the bulk solutions, and which are the DNA variables, and you see the zero values is before start the process. The values are in rest conditions.
Roman sir,
Yes, sir.
This is not, it's a constant, but say.
Yes, yes, sir.
Okay.
Last day.
आयुष सामंत सिंह के अच्छी की नहीं ज्योति प्रकाश बेहरा
जो प्रकाश बेहरा मना करतला दे पाइलो काटी दे नहीं किसी समय सर्टिफिकेट को दिया जाए
No, sir. Very good afternoon to all of you, respected jury members, respected faculty colleagues, and my dear friends. I am Lashmita Rautray, going to present some of my PhD work, which is an intelligent path selection and resource allocation in multi-hub device-to-device communication. So these are my outlines. Going to the introduction. So device-to-device communication is basically defined as the direct communication between two mobile users or between two devices without traveling through the base station. So it is classified into two categories, inband and outband. When they are using the cellular spectrum, that is called as inband, and when they are using the unlicensed spectrum, that is called as outband. And under inband, it is again categorized into two types, underlay and overlay. And in underlay, the cellular user and device-to-device user, they are given the same spectrum, and in overlay, dedicated spectrum is given to the device users, and in outband, it is basically the unlicensed spectrum. It is again divided into two types, controlled and autonomous. When the cellular network controls the D2D communication links, that is known as controlled, and when the totally D2D users, they will use the spectrum without any control of the base station, that is known as autonomous. So the key components of device-to-device communication is spectrum sharing, proximity services, and direct communication. My objective is here I am optimizing two solutions. One is I am optimizing the multi-hub path between devices using a reinforcement learning technique, and I am comparing it with the conventional existing algorithms. And in my second part, I am optimizing the throughput by using another reinforcement learning technique by combining with a meta-heuristic algorithm. So this is my system model. I have taken a small system model where 10 device users here just to show the scenario how a D2D communication works here. So here I have taken D1, you can see here I have highlighted, D1 is my source and D3 is my destination. So here by using a multi-hub path, I am choosing another device which is that time idle, it is not working, not doing any sort of communication, that is D5. So by using the multi-hub path selection, the D5 is acting as a relay and it is creating a device-to-device communication path between the source and the destination. So hence 2D2D communication path is established here, D1 to D5 and D5 to D3. So here I told my objective, I have two objectives. So first objective is path selection. So here I have used a SINR based reinforcement learning technique, which is basically a Q learning technique. So in Q learning technique, the reward, they usually use a single reward function, but here I have used a composite reward function. I have combined the Euclidean distance between two devices and the SINR, the signal to interference noise ratio, and the energy consumption by the devices all together in my reward function. And in stage 2, I have done the resource allocation, where I have combined the proximal policy optimization, which is also a reinforcement learning technique, with a meta-heuristic algorithm and colony optimization together by making the hybrid of these two algorithms, and I have enhanced the throughput here. So this is my path loss model. This model, all these equations I have collected from my Rappaport book, which is a standard book. So here the free space path loss model, I have used the free space path loss model for basically I have taken the gigahertz channel. So gigahertz and the distance in kilometers. So I have taken this 20 log D plus 20 log FC plus 92.45, and I have taken FC as 2.4 gigahertz. This is for LTE and 5G application. This is the standard carrier frequency 2.4 gigahertz, and the attenuation factor is 10 to the power. I have taken the attenuation factor 10 to the minus path loss I have taken in dB. So I have converted it to a linear scale. Then from that I have calculated the effective channel gain power, which is Hij square Lij. Hij is the antenna gain, and from there I have calculated the signal to interference noise ratio, which is
multi-objective Q learning, as I told you, SINR, energy, and the distance I have combined together. So I have named it as EARSQ, and I have compared the computation time. So here in my graph, you can see that actually this is the same graph, but SEO is taking the computation time, more computation time. So hence in my second graph, figure 4b and figure 5b, I have just eliminated SEO to show the comparison between A-star, Dijkstra and my proposed algorithm. Here it is shown that my proposed algorithm shows very lesser computation time compared to other algorithms. You can see here, if I have taken 5 number of communication requests, that means 5 number of D2D communication establishment. For that, ERSQ is taking 0.2 millisecond. You can also notice, like for 50 number of communication requests, whereas Dijkstra, A-star, they are taking approximate 10 millisecond, ERSQ is taking 0.85 millisecond. And table 1 shows my simulation parameters. These are the parameters I have taken from the literature. And the number of training episodes is 500 here for ERSQ. So this is my second objective, where I have done throughput optimization. So here I have combined ant colony optimization with proximal policy optimization. So like Q learning, it works on state and action policy. Proximal policy optimization, it works on an arithmetic network. This is also an reinforcement learning technique. So here from the ant colony optimization, which are the best resources, we are getting best top 5 resources. From that only our PPO is choosing one best resource block allocation, which is increasing the throughput. Here the objective function is the throughput, and these are my results. I have compared with many existing algorithms from the literature, which is PSO, GWO, and hybrid PSO, GWO, SEO, PPO, all are the existing algorithms. So my algorithm is a hybridization of PPO and SEO. I have compared all these algorithms for the frequency 2.4 GHz, and I have taken the bandwidth 180 kHz. And it is in that my proposed algorithm gives the better result. It is in terms of 17.4 Mbps. So these are the discussions. So here I have proposed a modified Q learning algorithm for multi-hub path selection, where the reward is a composite function based on Euclidean distance, SINR, and energy. It is compared with all the extra, and SEO. And my algorithm. So I have done the throughput optimization as well as multi-hub path selection. So both the algorithms have used reinforcement learning algorithms, and it is giving better result. Thank you. So here there is just one issue I find, that you talk to MBPS, but height doesn't make you the MBPS, it also JPPS.
Yes, ma'am. I have also worked, that is for the short range communication. I have taken that 26 gigahertz, that work already I have done. 26 gigahertz frequency, bandwidth 100 megahertz. In that I got in Gbps, but I didn't show that result.
No, 26 gigahertz for carrier frequency.
Yes.
Where is that used?
26 millimeters wave communication. I have not shown that here. Madam,
That is all right. You talked of WSL and IoT.
Yes.
And primarily in the ISM band.
Here I have taken only 2.4 gigahertz and 180 kilohertz. That is not given in Gbps. It is given in Mbps only. If I am taking short range and line of sight communication, let's say for I worked recently, I worked on that. That is 26 gigahertz frequency, and bandwidth I have taken 100 megahertz. There I am getting some like 17 Gbps.
No, 100 megahertz bandwidth, how will you get 17 Gbps? Which modulation scheme then you are using? It doesn't seem possible. Because bandwidth is directly related to the data rate that you are using.
Yes, that formula only.
No. Because you are using a multi-level modulation scheme, such kind of high data
But
rate.
modulation scheme I am not actually.
And how it will be possible?
Physical layer I am completely working on network layer. Modulation scheme I am not considering. I am only considering like the relay fading, I am adding the fading and noise effect and interference, and there only I am calculating SINR. And then we love the
100
SINR.
megahertz of bandwidth means even if you use 64 WAM, then at most 600 Mbps of data rate will be possible. At most peak data.
You check it.
Actually I am not working on physical layer, so I
I
don't
know it doesn't have to, because bandwidth and data rate, they are directly related to each other. So even if you go for network layer, physical layer if it is not allowing it, how it will be very possible? So you need to check. Okay, ma'am. Thank you. Thank you. Thank you.
Thank you for your presentations. Now I would like to request Professor Achyutananda Acharya sir, Professor in charge, Shodh, to felicitate Professor Srivastava Behra sir and Professor Madhav Chandra sir. Sir. Now I would kindly request Professor Aruna Tripathi ma'am, Dean PGSR, to felicitate Professor Srivastava Behra sir and Professor Madhav Chandra sir.
କାଟି ଦିଅ ପଟା ହଉ ହଉ
से जो आगे घंटा जाने दस्ता वो बेसिस रे हमें ये करेगा
ସେଇଟା ଅଛି
ରମେଶଚନ୍ଦ୍ର ମିଶ୍ର absent ଗୋପାଳ କୃଷ୍ଣ ଦାସ
टाइमिंग विषय कह देछन तो माने प्रेजेंटेशन
7 to 8 minutes and 2-3 minutes for question answers.
10 minutes maximum upper limit. So you can avoid all this introduction or brief you can.
आपण ताकले से रमेशचंद्र मिश्र तांका नारे आसन बोली लिखि दो
हम लिखी
Again, sir.
आपण ससन चैप्टर
हां
ससन चैप्टर ना आपण वाले डिवीजन प्रेजेंटली एब्सेंट
लास्ट वन लगे करू ना
ନା ସାର୍ ଆକ୍ଚୁଆଲି ଟିକେ ଅପେକ୍ଷା କରିବା ଠିକ୍ ଅଛି ନହେଲେ ମୁଁ ଆଉ ଗୋଟେ ବି ଅଛି ଆମେ ଓହୋ ତାହେଲେ ଠିକ୍ ଅଛି ଆବସେଣ୍ଟ
टाइम में दिया से और मीडिया से ना खाली करता बोली साहब
ना ये कर दे ऑनलाइन कर दे ना
ମୁଁ ବି ସେ ଅଭ୍ୟାରି ଫାର୍ଷ୍ଟ ହାଫରେ ବି ଦି ଜଣ ଆସିନଥିଲେ ସେ ଅଭ୍ୟାରି ଆମ ଦେଇ ସବୁ ସୁବିଧା ଅଛି ବର୍ତ୍ତମାନ ସବୁ ପ୍ରେଜେଣ୍ଟ ଅଛି
ଡେଟରେ ଅନଲାइन इंटरव्यू होची
ସେଇଆ
ऑनलाइन इंटरव्यू होची सिलेक्शन नहीं कि लोग आईआईटी रे जॉइन करू Your time starts now.
Good afternoon, sir. My presentation is on development and demonstration of an effective bulletproofing glass using numerical simulation and experimental brain design. Introduction. The development of composite bulletproof glass involves several key enhancements in material science and engineering. Bulletproof ballistic glass is designed to absorb and dissipate energy of projectiles to prevent penetration. It's mostly used in public buildings, embassies, VIP, presidential protection and enforcement vehicles, etc. As per the literature study, we find that some modern advanced material can reduce the weight and cost of bulletproof glass, like aluminum oxide in the outer layer in place of polymer layer, which is used conventionally. So we are planning to add some material like acrylic or glass clad polycarbonate, etc. Gaps and limitation and motivation. Bulletproof glasses currently available are heavy, thick, costly. Continuous research is needed to minimize the weight and thickness. Numerical treatment of
sir
bulletproof glasses.
ଆପଣ next ଚିପିବେ ତାହେଲେ ସ୍ଲାଇଡରେ ଯିବ
Yes, sir. Numerical treatment of bulletproofing glass is rare as per the literature reviews concerned. It includes structural effect and impedance analysis, which is not simple. Numerical analysis required in load and drawing research expensive time. There is no literature on thermal effects. Certain thermal factors is essential when considering the deployment and military of military vehicles in harsh weather. Optimization of cost aspect study and pressure on carbon fiber. We are working on that. Objectives. To develop and demonstrate light and effective bulletproof glass to be used for commercial vehicle and military vehicles. To simulate impedance analysis on bulletproof glass based on the velocity or momentum of the burning rods. Experimental verification on manufacture of bulletproof glass to carry out thermal and radiation analysis on the manufactured glass. Economic study of the proposed novel bulletproof glass. Brief outline of the research proposals. First, we plan to lay manufacture of the composite combining the layers of different materials having different properties by heat and pressure to make it a single piece, so that both properties of the both material can be achieved. Similarly, this has been done by lamination method. After that, testing and quality control will be done. Economic study of the novel bulletproof glass is also in our part. These are the literature review and references. Thank you. Yes.
Sir, madam. Again, structural analysis. सॉफ्टवेयर यूज करी एफईए करी एनालिसिस के एफईए करी ଆମର ସୁଧାଂଶୁ ସାର୍ ଆଉ ପରିଡ଼ା ସାର୍ ଆଜ୍ଞା ଷ୍ଟାର୍ଟ ଏଟା different material different material having different properties will be stacked together by applying heat and pressure so that it will be act as a single material and both the properties can be achieved. So our aim is to minimize the thickness and lightweight. एक्जिस्टिंग भी सिंगल स्ट्रक्चर ना बहुत प्रकार भेराइटी अच्छी आम ताठू गोटे थिकनेस मिनिमम कर लाइट वेट करी तो अनलिमिटेड आम आम स्टडी अनुसार सर बर्तमान 4-5टा मैडम पाई हाँ हेवी अच्छी आ कॉस्टली अच्छी थिकनेस अच्छी अधिका Sir. Sir.
It should not give a scratch mark also.
Sir.
So what do you think of that in that line?
Like study of strain energy.
Strain, rate of strain.
And how you will make it scratch proof also? Rebound kariyo. Rebound kariyo.
And preparation of bulletproof gas. Mind it to how shall I prepare?
Sir, सिपेट सर सर कत सिपेट रे हम करी बोली प्लान करथलु सर Sir, we will purchase the material. Okay, momentum टा heat dissipation होबो energy absorption होबो से material टा करिवो
maybe you are doing some improvement or some modification on that. It is just from layman's point of view. Conservation of momentum, conservation of angular momentum, conservation of moment and conservation of energy. These two principles hold good everywhere.
आम बर्तमान मेटेरियालटा बनवाई चेष्टा करूँ सीपेट तापर से आनालिसिस कर सफ्टवेयर आज्ञा ना रिबाउंड चांसेस बहुत कम आम डिसिपेसन कर हिट और से मेटेरियालटा फ्लेक्स लाइक स्ट्रक्चर बन रिबाउंड बहुत डिफिकल्ट बहुत स्मॉल कम वेलोसिटी हो पार कहीं 350 रु 1300 मीटर पर सेकेंड वेलोसिटी जाके बर्तमान बुलेट अवेलेबल अच्छे थैंक यू सर सर सर
I am Joseph Satpathy from School of Mechanical Sciences. Okay, here my topic is hybrid optimization of laser drilling of aluminum 6063. That here I am using two different methods and integrating it. The two different methods are Taguchi design, that is your statistical approach, and machine learning for multilinear regression. The core goal is to give a hybrid data-driven approach where we can minimize the cost by taking some trial and error methods, and using MLR, that is machine learning, we can optimize the cost and give the product efficiency. Here the problem that has faced that while we doing any test, we are at previous what we have done, that we are doing different types of trial and error method. If there is 5 levels and 3 different parameters are there, then we have to usually do 125 test cases. But using machine learning, we can do with L25 Taguchi array, that is for Taguchi. L25 array, we can optimize it in only 25 level. We don't need 125 test, we only can done it in 25 test. The material is aluminum 6063, where though it is a high extruded material, its property is high extruded, so the material can be a alloy of magnesium and silicon. Sorry, keyboard one. Okay. This is the Taguchi experimental design, where I have taken orthogonal array, that is of L25 matrix, where 5 labels are there for 3 different parameters. The inputs have been shown here. 3 parameters are pulse, frequency, and scanning speed. The most optimized parameters are at power 20 kilowatt and frequency 25 and scanning speed 130. First, we have done 3 types where we can, so first we have considered material removal rate, heat affected zone, and circularity at both entry and exit. What material removal rate means, how much the material removed, means it can be measured by its volume that is removed. And heat affected zone means how much heat affected when a laser is affecting on a hole and its surrounding. And circularity and exit, at circularity and exit, where is the hole is, we usually measure is whether the hole is circular or it, due to some error or due to some heat, thermal damage, it is going to the oval shape.
The topic on a novel meta hedgehog hibernation optimization for cloud. First is a heuristic approach. So
125 number of experiment, to reduce that experiment, you come down to 25. You are told 25 number of experiment. You could buy PhD. 125 extra, hardly it will take 10. Why you stay? Had it been 1000 experiment, then you optimally come down to 25. It is only 125 experiment you have to do. Then how do we find that 20, 25, 130 is the best? We have solved some pedagogy method. Array you have shown, second array you have shown, and you told that it is 20, 25, 130 is the best. How you conclude that and what is the method?
Getting many times.
Without a slide there. How you put it? Probably fourth slide. This one. You have told them. Can you explain L4, L25, L50? What are those things?
There's a levels.
Now what? You have written L25 matrix, but you have given L50. And from here you told that 20, 25 and 130 is the best. How you conclude that that is the best parameter? Then go to your beta 0, beta 1, beta 2, beta 3. You have told 3 levels. But what does it mean? Beta 0, beta 1, 3 levels, there are 4 levels.
Beta 0 is the starting point.
But you told me 3 levels. Now it is,
parameters are there.
what is beta 0, beta 1?
Beta
What is the
0
beta
the
factor?
coefficient for power, and beta 1 is the coefficient for power, beta 2 is the coefficient for frequency. And similarly, beta 3 is the coefficient of for speed.
What is the error you have taken here? Any feedback you have taken? Error to minimize the error. What is the error you have considered here?
The unwanted noise or the machine vibration.
What is that error? What is that error? Percentage of error कितने नहीं किया? और ताकि minimize करिए तो कितने feedback you नहीं करिए?
Sir.
मैडम टाइम नहीं गया ना? Okay, thank you. आपके बताइए. ये.
Next, Jitendra Naik.
नहीं सॉरी सत्य सौम्य परिजा नहीं तार तो से तो चारियाडे कर देछि ना वार्ड एनालिसिस रे जाउ वार्ड
सत्य सौम्य परिजा
सूरज समूह से
सूरज समूह ऑप्शन
भाई आपन का बहुत ऑप्शन
बढ़िया ना आपण इंटेग्रेशन जी ଆପଣ ଦରକାର 430
ना ना सर
ସେଇଟା ଆପଣ ଆକ୍ସନ ୟୁ ହାଭ୍ ଟୁ ଟେକ୍
very purpose of not holding the reserve complete sir तो कोई नहीं
yes
नहीं महादेव पति his will be deferred by 1 year because he has defaulted 2 times promised again 1 year सब तो बेटा तो भी आउट ऑफ इंडिया के डोंट
I will present the research experimental analysis of power consumption and time taken for PLA and ABS material creativity. Introduction that basically FDM is called fused deposition modeling is the most common in creativity. It works by melting plastic filament like ABS and PL. ABS is called acrylatyl butyl styrene and PL is polylactic acid. And stacking them in layer to build an object. Different plastic need different melt. ABS significantly increases the total energy needed for the fluid. The finding will provide empirical data for the users, manufacturers to better understand and the energy cost and environmental footprint associated with these common materials like ABS and PL. And this is the comparison of PLA and ABS material. In hardness, PLA is slightly harder than ABS
That means PLA part is less likely to get a formatted mark if you press it fingernail into it. In the case of Young's modulus, it measures how much material exists like bending when you pull or push on it. In the case of elasticity, how much the material can stress or bend without any breaking and then snap back into the original shape. In the case of brittleness, ABS is slightly more brittle in the specific compression, so the real program statement. Additive manufacturing, popularly known as 3D printing, it adds material layer by layer to build an object from the scratch. It's better because you can design something on a computer and have a physical version in your hand in some hours, not some weeks. It's low cost and entry operation simplicity have placed FDM printers in the workshop, classroom and homes. These machines are very cheap and easy to use. And this is the graphical presentation of this is the 3D printer and this is the ABS material and this one is the PLA material. And design of the experiment is one of the cube. This is the 3D printer I use in my experiment. And its specification is its nozzle speed is 40 to 50 ml per second, and nozzle temperature in the case of polylactic acid, the nozzle temperature is 180 to 250 degree, and bed temperature is almost normal, 55 to 60. In case of ABS, the nozzle temperature is almost 240 to 280 and the bed temperature is always 80 to 90 or 80 to 100. The nozzle size of the 3D printer is 0.6 mm. And the design of the experiment, these are the 9 experimental terms, and this the NS is the nozzle speed, NT is the nozzle temperature, and LT is the layer thickness. There are nozzle speeds are between 30, 40 and 50 in all 9 experimental terms, and nozzle temperatures are 250 or 255 or 260. The layer thickness is 0.0, 0.1, 0.15, 0.50. The legend analysis, these two images show how different 3D printing material ABS and PLA perform across the various tests. In the series 3, there are in the series 3 of the both table shows all the power consumptions in the different experimental terms. These are 30, 40, 50. These are the nozzle speeds in both PLA and ABS. The comparison of NT and time taken for PLA. Here is the nozzle temperature and the time taken. In the fast table, there are all the nozzle temperature and in the series 2 there are the times. Conclusion. In the battle of the energy efficiency, PLA wins by a lot. It uses much less power than often 2-3 times less than ABS. The main reason is ABS is more expensive to run with the heated bed. ABS needs the printer base to stay very hot, around 100 degrees Celsius. The entire time the printing. PLA does not need that much of time. It starts faster and saves power.
Thank you. You go to your graphical presentation where you have shown the material testing. Second, third slide. Why the brittleness is so gap is there? All others are very close. have you done yourself all this analysis? They saw you have taken this from the literature survey. This hardness, Young's modulus, elasticity. What do you mean by this elasticity? What do you mean? You have written Young's modulus. What do you mean by elasticity?
Sir, the material can stretch or bend without any breaking.
No, that is not the
elasticity brought from generic term.
Generic term. It should not be there. Okay. And this brittleness, you just that is, you might have it is an error. Whenever you are presenting, it should all this should be similar type. Then you have done this in yourself, all this, or you have taken it from the literature survey.
Sir,
now you haven't shown any machine or anything you have shown. That's why I was asking.
Scale level 0, 1, 0, 1.
sir,
Axis y axis sir पचास कौन होची?
0, 1, 0, 1.
Suppose 0, 1, 0, 1, 0, 1.
Staggered winners.
Okay, ठीक है. Thank you. Okay. Next. Namaskar, Jai Jagannath. I am Abhishek Mohanty, research scholar from School of Mechanical Sciences. My supervisor is Dr. Datiranjan Das. Here, my topic is free and force vibration characteristics of multi-fabric bidirectional functionally graded composite sandwich plates. Basically, I am working on plates here. What is FGM? First of all, we are coming to the point. FGM, functionally graded material. It is a kind of material when we are actually making a gradation according to our need with two or more different materials. When we are actually willing to get some certain desired properties of the material, at that point we may get, like in the figure you can see, this is the layout of sandwich plate of the functionally graded material. FGM is functionally graded material and the property is varied with gradation. We can achieve our desired property with appropriate selection of the material, and this is widely used in aerospace, automobile engineering and construction sectors. We have used multiple materials like glass fiber and carbon fiber here. The prepared materials are made in X and Y directions alternatively according to the varied properties which we have taken. Sir, I have showed the product. That is a sample from different plates which I have actually made from hand layout process. My objectives are to develop multi-fabric bidirectional functionally graded composite sandwich plate, and those are the samples of that plates. To experimentally investigate the free vibration characteristics, that is natural frequency and mode shapes of the developed functionally graded sandwich plates under different boundary conditions, that is clamp, free and simply supported, etc. To evaluate the force vibration response of the fabricated plates and analyze parameters such as amplitude, resonance behavior and frequency response functions. To compare experimental result with analytical and numerical predictions using Reddy's third order shear deformation theory, DSDT, and for the core and FSDT, first order shear deformation theory for the H6. The core is of honeycomb core
structure. You can also see from that sample that in between that, that is actually two kind of core I have used. One is from PLA and another is one from PET. To establish optimized design guidelines for lightweight, high stiffness and vibration resistant functionally graded composites and structures for advanced engineering applications, which I am also using in a project to make the body part of the automobiles. The material I have used is carbon fiber bidirectional woven fabric that I will show in the figure in the next slide. E-glass, that is glass fiber, that is also bidirectionally woven. Fiber were woven within individual fabric layers in varying carbon and glass proportions to achieve functional gradations. Epoxy resin is the matrix. This is the picture where I can show every figure, every photo of the each and every layer is I have woven with hand layer process. The first we can see 100% glass fiber, GF is glass fiber and CF is carbon fiber. Accordingly I have varied with woven bunila bhali sir gote mane tar suta bar kariki buna heichi, each and every thread I have used and the hand layer buni ki kara heichi. And the naming are FRFGSP1, FRFGSP2. These are like fiber reinforced functionally graded sandwich plate 1. These are the full form of that. Similarly, I have taken 6 samples. 2 are without honeycomb core and 100% glass fiber and carbon fiber. 100% glass fiber material and 100% carbon fiber material. And eventually I have varied the composition. Even I have added the honeycomb core. Even you can check the materials and you will find the layers also. The method I have used, the natural frequencies and the mode cell were determined using impact hammer test method. With the response signal was captured and analyzed to be using FFT analyzer software. A mechanical shaker was used to apply harmonic excitation. Phase sheets were modeled using FSBT and the behavior was modeled using TSDT, third shear deformation theory. Finite element modeling was carried out using ANSYS 16.0. Application and of functionally graded sandwich plate, 6-layer bidirectional woven fabric laminates were prepared using the hand layer process. Carbon and glass fibers were woven within each layer to create functional gradation. Different gradation configurations were designed. Higher carbon content at outer layer and gradual transition towards glass fiber. The thing is that why I have used the carbon fiber and glass fiber each. Though glass fiber is easily available and cheap and carbon fiber is relatively costlier. But we are also trying to minimize the cost. If we are able to succeed in that, we will able to produce carbon fiber from the lignin, that is from the grass and the straw, etc. That in that case we will go completely towards the carbon fiber. The laminates were cured under controlled temperature and pressure to ensure proper bonding and uniform thickness. The process, the mold, everything we have prepared according to our samples. The results are we have found these results. The HC means core thickness, HF means face thickness. These are the comparison, the mode vibration with the prior literature review, and even we have made compared with present theory. The mesh we have used a finite element analysis, and the mesh size 1 into 1, 1.5 into 1.5, etc. These are the data. This is another comparison versus the mode number and frequency. The CC are actually the clamp. CF is clamp free. C is C for clamp and S for single supported. These are some of the graphs I have found. According to the according to this graph, we have found some conclusion. Both present theory and FEA shows adequate closeness with result in analyzing the model response of sandwich structures, and the error percentage is found to be minimum. It is revealed that though preparation of fiber reinforced functionally graded sandwich plate is a hectic task, a considerable increase in strength of the FF is observed. The plate stiffness is directly proportional to the thickness of the unit cell wall and become constant beyond 1.25 millimeter. Actually we have found. Similarly, a linear increase of FF with HC by FF. HC means the thickness of the core and HF is the thickness of the face is observed. From numerical analysis, it is observed that the stiffness of the plates is increased by increasing the aspect ratio of the plates, and is observed in rise of FF. Selection of the PET over PLA is a better choice as a core material sandwich plates, with PET material as honeycomb core, so 7 to 8% more FF than the sandwich structures made with honeycomb core. The functional gradation of the glass and carbon fiber in the fabrics used in the core sheet bridge a balance between the strength and flexibility in FR, FG, SP, fiber reinforced functionally graded sandwich plates. The sandwich plate 1 and sandwich plate 2 have higher stability than FRPC 1, about 7 to 8% increase. Thank you.
So the diagram showing back. Number the line number. Yeah, this one. So what is the size of this metal screw? Yes, bar side number provided.
25 mm, 25 cm, right?
How much is 25? Total is 25.
Again?
Total is 25. Width.
Width,
thickness.
Thickness का sir 10 less than 10 mm.
This one. But why the cross section?
ସେଇଟା ନୁହେଁ sir. ଅଲଗା ସେଇଟା ଡାହାଣ ଅଛି 10 to 12 ସେଇଟା ନୁହେଁ ସେଇଟା ଅଲଗା. ସେଇଟା କମ ହେବ ସେଇଟା only ତା ଭିତରେ honeycomb core ନାହିଁ.
ଏଇଟା ତ ନାହିଁ.
ଏଇଟା 10 ରୁ 12 ଭିତରେ ଅଛି. ମାନେ actually ସମ୍ଭବ ନୁହେଁ, practically impossible to make the perfect shape. ଆମେ actually hand layer process ରେ କରୁଛୁ ହେଇପାରିବ.
How you have created this honeycomb?
sir ସେଇଟା 3D printing ହେଇଛି.
ଏଇଟା 3D printing ଅଛି.
honeycomb ଟା 3D printing ହେଇଛି. जो material गुडा जो variation है ला, मतलब 80% carbon fiber है ला, 20%.
How you have 3D printed this thing? Core ଟା ତ honeycomb use କରୁଛ ନା?
core भी तो print କରୁଛୁ.
It doesn't look like honeycomb.
सर देखा होनी किंतु सेटा मु सेटी फोटो अछि. मुझे कोड काटी दीची ना सर मुझे से.
Go back 2 slide back. When you are shown how you have ensured that this parameter is updated? No, it doesn't.
सर मु एक्चुअली honeycomb मतलब फर्स्ट 3D print कर ली, तार पर फर्स्ट देखो ए फोटो देखो. फर्स्ट कौन गोटे पेपर
No,
सर मुझे एटा मन करो भावंतु फेस शीट ता ऊपर honeycomb रो गोटे प्लेट रहला. honeycomb को प्लेट पूरा रखि दे बुझि गले. ता ऊपर आ गोटे
honeycomb material is from what?
PLA and PET अलग अछि. किछकर PLA अछि, किछकर PET अछि.
But this doesn't look like PLA or PET. I will PLA PET good is.
तो जना पड़ुने एपोक्सी ढांकी देछि बुझि कि ए जो मझे रे अपन कोना होले सेटा एक्चुअली देखन टिक बंदी कि देखिबे जदी ए पर्सन रो 1% तो अछि honeycomb कोटा. तो काटी दिने अभी के एपोक्सी भी पसी जाइछि सेटा एमति कन्फ्यूजन.
माने या भीतर कोना
भीतर टिके एपोक्सी भी पसी जाइछि कि नै माडी की प्रेस कर दिया.
See, my confusion is this is what? This is sample, right? Now this actually sample contains the honeycomb structure, right? honeycomb आधे तो काटी दी चलो. आधे कितना यूज कर रहे हो?
या भी दी 1 2 3 4 टा चारटा
ने लंबा चार्ट.
हां एपटे नाही एटा हे परिबन ना जो काटी दे सारली.
So the sample what you have tested
is not there, right? How know that honeycomb? You cannot assume na. So where honeycomb?
It was
so that we come.
Same.
Both are same.
How you have 3D printed?
Same.
सर सेटा मु ये मोर पेपर देखे देली सर माने मो पत्र मो मेटेरियल को देखे देली
इधर 3D प्रिंटिंग का कोड है
कॉलेज में कुछ
ये हमर ये ना
हां
अरे ये कॉलेज में यूनिवर्सिटी
सॉरी
no what is your standard whenever you are so test करते
Again?
कौन टेस्ट करते
सर डिफरेंट टेस्ट अछि मो सब कहि परिबे
नहीं
एक्चुअली
कौन तुम कौन करछ तो यार एक्सपेरिमेंट टेस्टिंग करछ ना
हां
कौन करो
इम्पैक्ट कराई छी
जो इम्पैक्ट करछ व्हाट इज द सैंपल व्हाट इज द सैंपल साइज
सर
टेकिंग एनी स्टैंडर्ड सैंपल और एनी रैंडम सैंपल दैट इज द
स्टैंडर्ड
हां तो को सैंपल नो
सर सेटा फोटो देनी सर सेटा एक्चुअली फोटो देनी मु देखे
जोटा दरकार है
टॉप वाला पेपर ना
जोटा इंपोर्टेंट टोटल दे
जरा डिफरेंटली एसएमई सैंपल
एक्चुअली 12 टा पेज पाइला तो सर सब दे
अरे जो परसेंट
12 टा कंबाइन करियो जेती पीपीटी अछि ना 4 टा पेज रे करबा
कि आगु वाला रिजल्ट दे
ठीक है परसेंटेज जोड़ा देइछ कोन परसेंटेज सर मास ना वॉल्यूम
दिस इज योर वर्क
हां
अभी बैक कला बैक
2020 वाला पेपर आसी
ये लगे जो देखे
26 रानी का सेंटर ना जिनसा
एटा सर
ये जो
की काम होने
परसेंटेज
एटा
40% से
तो सर एटा भाई वॉल्यूम
वॉल्यूम ये ऑल इंश्योर दैट 40% बाय वॉल्यूम
सर सेटा मु देखो एक्चुअली कोन थाए कि सीट रे आसे कार्बन फाइबर ग्लास फाइबर सीट रे आसे तो मु कोन करके कैलकुलेशन करके तार गोटे सीट हिसाब रे काढी देली सीट सॉरी माने थ्रेड हिसाब रे गोटे बाहर कर देली माने करो भाबंतु गोटे मैट्रिक्स अछि 10 बाय 10 टा थ्रेड अछि कार्बन फाइबर आ गोटे बाहर कर 10 टा थ्रेड ग्लास फाइबर तो माने करो ता भीतर मु गोटे थ्रेड काढी देली आ गोटे थ्रेड पके देली तो 10% एड ही गला बुझि पाली माने करो गोटे कार्बन फाइबर सीट रु मु गोटे थ्रेड काढी देली आ ग्लास फाइबर गोटे थ्रेड ता भीतर पके देली तो सेटा हे गला 10% ग्लास फाइबर और 90% कार्बन फाइबर बुझि पाले तो सही हिसाब से
कार्बन
that is weight by weight percentage
ना
volume percentage
हां वॉल्यूम
कार्बन बने छै ना आतर ब्रांच
कार्बन फाइबर सर किनी
केते परसेंट कार्बन छै
कार्बन फाइबर देखि जाबो सेटा जोड़ा 100% कार्बन
तर कार्बन को तार फाइबर नहीं तो
you have handmade this
मैट्रिक्स अछि ना तरे
हां
एटा हम केमिति कहला how to pressurize this
सर मोल्ड
रखी ता प्रेशर दो इन द वाटर
हां एक्चुअली हमें बहुत करा जाय कि अपन आरआर सर को बजार दे
We have given
Arada sir not here. You are here. You have to explain the questions.
हम फोटो देख के सर फोटो
actually started with 415. Actually, you have to wind up by 4:30. That means next.
Why
So already we have said 4:48 में validate करेंगे.
Good afternoon. My topic is fabrication and mechanical evaluation of ABS, polymeric, polymer composites, film PETG. In addition to that, I have also taken this polymeric. These are the overview of the presentations. Introduction. A composite sandwich beam is a lightweight structural element made up of two strong outer layers, bonded to a thick but lightweight core. In my case, I have taken this ABS, designed to achieve high stiffness and strength with minimum weight. Various core geometry exist, including honeycomb, foam, corrugated structures, and tubular or cellular cores. These geometry detects the beam's properties, providing high strength to weight ratio, high bending stiffness, and impact absorptions, which are critical in aerospace, marine, and construction applications. The need of sandwich core beams is to provide high strength and stiffness with very low weight. It helps in withstanding bending and shear loads efficiently, saving materials and reducing overweight, increasing structural stability and durability. The applications are in aircraft structures, wings and fuselage, tail sections, door panels, in spacecraft components, that is satellite panels, fairing and nose cones, payload bay doors, in helicopters, rotor blades, cabin floors and doors, rocket and launch vehicle structures, unmanned aerial vehicles or drones. Nowadays, widely it is used. In literature survey review, we found that actually, particularly experimentally, it is lessly used, particularly this honeycomb ABS with this polyurethane and PETG. So that a research gap, what people found, that from the above literature survey, it is evident that numerous research are done, especially on numerical simulations, and the finite element are we say here of the beams, plates is, however, a very limited amount of work are performed on experimental details on manufacturing, testing, vibration analysis of the hybrid composites. The objective of these experiments, sandwich structure are used in aircrafts for that. Understand and optimize the strength, stiffness and other mechanical behaviors of composite materials by investigating the effects of different fiber types, matrix materials, reinforcement geometric and manufacturing process. The vibration characteristics of multi-layer sandwich beams will be numerically investigated, validated with vibration experiments. These are the project outline. In project outline, selection of polymers, that part is over. Selection of core structure, that is over. And selection of skin material, that actually we have to. Then that next is evaluation mechanical properties, that is in future experiment will be. This is the methodology. Printing of sample in 3D printer, that is over. Filling the gaps, one part that is over. Additional skin metal sheets, that part actually we will be doing soon. Evaluation of mechanical properties, optimization of the skin and core parameters. And this is the flow charts. And this is the manual fabrications. We have taken this level 1, level 2, level 3, level 4 and level 5. In the level 1, that is the printing of samples. In level 2, filling up the gaps, that is level 4. Level 3, adhesion of skin metal sheets, that actually will be doing in the next step. Level 4, that is mechanical strength, that will be future work, and optimization skin and core parameters. In the level 1, that FDM process, I can show because it is short, I am just showing. This is the 3D printing machine actually in our lab it is having, and these are the parameters and specifications. And this is actually two structures I have taken, that is one is 10 mm and one is 6 mm. Actually the first part, actually first experiments we have taken, this is 10 mm honeycomb structure with 2 mm thickness, and the sample size is 162 mm by 10 mm. This is the 6 mm honeycomb structures. This is ABS materials out of that made by this 3D printing. And the filling material is PETG in one sample and other sample PU. Actually recently we have done this. This is the vertical. This is 162 into 62 into 6 mm. This is the larger scale, larger pore, and this is the smaller. Actually side by side, you can show you. And during the experiment, after developing the honeycomb structure made out of ABS plastics in MDM process, the following work has been executed as detailed below. The honeycomb structure is filled with the hybrid composites with PETG. All the mechanical properties are evaluated by different metals testing method, theoretical, natural frequency, and mode shapes are found by different end conditions using Hamilton's principle, and so that this is the PETG materials. And in this slide, actually, I have brought this few things. This is the theoretical analysis of two-layer beam. This is the work done, that is the potential energy by using this Hamilton's principles. And this is the kinetic energy, and this is the external energy. And this is the governing equation. And these are the boundary conditions for cantilever beam. And this is the work done, the mode of cell difference in azimuth frequency of cantilever beam. And this is the first, second, and third mode shapes for cantilever beam. And this is the experimental to be done, which is our part actually samples we made. Actually, this part will be done in the next step. And optimization of core fiber, already I have discussed this. And joining of the skin layer, that is level 3, that is pending. And after that, actually we will be evaluating the test results. And conclusion, after application of composite adhesive mechanical properties test, tensile test, flexible impact test, and analysis test are performed on them to eliminate their mechanical characteristics. The test results of two composites are compared. From the comparison of tensile test results of two composites, it is found that the fabricated composite ABS PETG has higher tensile stress and tensile strength than other composite metals. Higher tensile strength of PETG filled hybrid ABS composites indicates that the composite metals deforms more before fractures. So the composite is more ductile and suitable for diameter. Funding source, the authors acknowledged OUTR and the Secretary Biosensor providing the research facilities and fundings. And these are the reference. Thank you.
Any questions from audience?
Thank you for the
Have you done tensile test?
Yes, actually, that result not is incorporated in this presentation.
So for that test you are making
Actually, the thing that actually after that actually I have to put that skill there. After that actually that test actually one will be without skin, another test will be with skin. That skin that is pending, this is level 3 that is pending.
So not that
that skill there actually I have not attached on this subject.
But the maximum tensile test place is higher.
That actually before skin actually we have taken, but that's why actually I am not incorporated in this.
So it is STM standard sample or the sample is field actually?
This STM standard actually will follow.
Which standard for the test? What are the STM standard?
STM 173.
Okay, thank you, sir.
Everything in time.
Scholars, can you please go outside? Okay, you will be done. Okay, actually.
On the side of the
Thank you, sir.
I now kindly request Professor Aruna Tripathi ma'am, Dean DHARA, and Professor Ramesh Malik sir to felicitate Professor Loknath Panda sir and Professor Saroj Kumar Pradhan sir. Ma'am and sir, please.